So we are doing exercise 8.2. We've done the first 3 questions and 6th question. Question number 4 here. You've been given that ABCD is a trapezium in which AB is parallel to DC, BD is the diagonal, and E is the midpoint of side AD. So E is the midpoint. You can mark that these two parts will be equal. And there is a line which has been drawn through E, and it is parallel to AB. So there are 2 things given here. AB is parallel to DC. The line which passes through E is also parallel to AB. So you can just mark EF is parallel to AB, AB is parallel to DC. So what do you get from here is that there are 3 parallel lines here. The line which passes through E meets the opposite side BC at point F. You have to prove that point F is the midpoint of side BC. E is given to be midpoint. And you have to prove that this point F is the midpoint of the opposite side. Now, you have 2 results before this exercise. One is the midpoint theorem and the other one is the converse of midpoint theorem. How do we find out which one will be applicable here? Depending on how many midpoints are given to you. So if you compare the 2 results, if you remember, in case of midpoint theorem, you're given 2 midpoints. For the midpoints, for 2 sides of a triangle, the midpoints are given, and the line segment which connects those midpoints is parallel to the 3rd side. So right now what's given to us is we are given 1 midpoint, we are given the condition of parallel lines, and then eventually we have to prove that this line which has been drawn through the midpoint E is meeting the opposite side at the midpoint as well. So in order to prove this, first of all, you need to remember this, that midpoint theorem or converse of midpoint theorem will only be applicable in a triangle. Converse and midpoint theorem, both these theorems are only applicable in triangles. So the first thing you want to ensure is that you draw one of the diagonals. Right now they have drawn BD diagonal, you can draw any diagonal. In case you're simply given that there is a trapezium, suppose you're simply given that ABCD is a trapezium, E is the midpoint of side AD, and there is a line which passes through E, let's say the name of the line is L, and it meets the opposite side at F, and this line L is parallel to one of the sides. You have to prove that F is the midpoint. Now, you can see the difference in the 2 figures. There is just one difference, that the diagonal is not given in the one that I have drawn myself. So in that case, you will make construction. You will write down construction to draw one of the diagonals. So right now they have done something for you. They have drawn the diagonal, and because of this diagonal, you actually get 2 triangles. So because of this diagonal, that's why this diagonal is important here. So you can draw, there is this line which passes through here from E. This is parallel to the base. And since this is parallel to this one, the further part will also be parallel to DC. This is what you get. The 2 parts which you can obtain from here. I'm going to mark this point of intersection as O. Now this is given to be midpoint. I'm going to apply converse of Pythagoras theorem. By converse of Pythagoras theorem, O will be the midpoint of the opposite side. We have midpoint.
Converse of midpoint theorem.
Yes, converse of midpoint theorem. We have midpoint of one side. The line through that midpoint is parallel to the 2nd side. Then eventually, the 3rd side, wherever is intersected, will be bisected as well. So O becomes the midpoint of, this is D, I have mistaken. Okay, this is ABD. I'm applying midpoint theorem, converse of midpoint theorem in this triangle, and then we will get O as the midpoint. Once you have O as the midpoint, you can then move to the 2nd triangle. Then O becomes the midpoint. Further, again, same theorem. You start from the midpoint, you draw a line parallel to the 2nd side, and then the 3rd side is intersected at F. F will also be the midpoint. So the result of converse of midpoint theorem is applied to a trapezium but with the help of two triangles, because directly आप apply नहीं कर सकते, आपको trapezium को दो parts में divide करना है. This can be done by drawing any diagonal, either BD or AC, both work. Right now, since BD is given, I'm going to work with BD. Let's write down the answer. This is given parallel to AB. So this is what actually the question will be in case they don't give you the diagonal. You will be only given a trapezium, midpoint of one side, line through that midpoint parallel to either of the parallel sides, and then the line meets the opposite side at a point. You have to prove that the point F is the midpoint. So right now, since diagonal BD is given to us, I don't have to worry, but otherwise I would be making construction. There will be construction, and you can mark the point of intersection as O. It will be construction, it's not, if it's not given. I'm going to take two triangles one by one. You can draw the triangles separately if you want. So in triangle ABD, now this is the first time we are using converse of midpoint theorem. So I'm going to write in detail, but later you can write down directly as well. E is midpoint of AD. This is one side of the triangle. EO is parallel to AB. Because EF is parallel to AB, therefore parts will also be parallel. This implies that O is midpoint of the side BD. So two conditions were given, one midpoint parallel, eventually we get the midpoint of the third side. This is the first result that we have obtained. Now I'm considering the second triangle that I have. Now, first thing we want to prove here is that this line segment joining OF is parallel to DC. You can write down, since EF is parallel to AB and DC is also parallel to AB. Therefore, EF will also be parallel to DC. This condition is required to be used in this triangle here. That's how I will be able to apply my converse. कन्वर्स के लिए पैरेलल की कंडीशन होनी चाहिए पहले से, तभी आप अप्लाई कर सकते हो. So that's why I've proved here that OF is parallel to DC. Now I can use my converse of midpoint theorem. in triangle BDC, O is the midpoint of one side. The line segment through O is parallel to the second side. This has been proved above. And this is because EF is parallel to DC. And then by converse of midpoint theorem, point F is the midpoint of the side BC. Any questions? Anyone with any questions? Is anyone writing down?
Yes, ma'am.
Yes, ma'am.
Let me know once it's done. Okay. Is it done? Shall we take up the next question?
Yes, ma'am.
Question number 5th. In a parallelogram ABCD given here, E and F are the midpoints of the sides AB and CD respectively. So E here is the midpoint of side AB, F is the midpoint of side DC or CD. Show that the line segments AF and CE trisect the diagonal BD. This is an important question. The diagonal BD is intersected at points P and Q. When you draw the line segment AF, diagonal BD gets intersected at point P. The line segment CE intersects the diagonal BD at point Q. You have to prove that P and Q trisect this diagonal. So what you need to prove here is that the three parts that you can see for the diagonal BD are equal. This is what you want to prove.
We can use the midpoint theorem in triangle APB and DQC.
In triangle APB and
DQC.
DQC. Okay, these are the two triangles. The triangles are correctly picked, but we cannot apply the midpoint theorem here because
We can say that AECF is a parallelogram.
yes, we will apply converse of Pythagoras theorem. We have one midpoint.
Yes,
we are
ma'am.
using the condition of parallel, so we will be using converse of midpoint theorem in order to prove that Q is the midpoint of PB and P is the midpoint of DQ, and then combining the two results, you get your answer. That's correct. So first thing we want to prove here is that this little figure here. Okay, I'll just go over the result that we want to use. हमने ये दो ट्राइंगल्स लेने हैं, ट्राइंगल APB और ट्राइंगल DQC. हम ये दो ट्राइंगल्स में वर्क करेंगे बिकॉज जो हमारी थ्योरम्स हैं मिड पॉइंट और कन्वर्स दोनों ट्राइंगल्स में अप्लाई होती हैं, तो हम ये दो ट्राइंगल्स में वर्क करेंगे. Now I have picked these triangles keeping in mind that E here is midpoint. मेरे पास एक मिड पॉइंट है और दूसरी तरफ जो ट्राइंगल बन रहा है उसमें F मिड पॉइंट है. तो अगर मैं अपनी कंडीशंस चेक करूं कन्वर्स अप्लाई करने के लिए या मिड पॉइंट थ्योरम अप्लाई करने के लिए, टू अप्लाई मिड पॉइंट थ्योरम मुझे दो साइड्स के मिड पॉइंट चाहिए, वो तो यहाँ पे पॉसिबल नहीं है. ट्राइंगल की दो साइड्स, रिमेंबर पैरेललोग्राम की दो साइड्स नहीं, ट्राइंगल की दो साइड्स के मिड पॉइंट्स चाहिए. तो जो मैंने ट्राइंगल्स यहाँ पे इंडिकेट किए हैं उन ट्राइंगल्स में सिर्फ एक एक साइड का मिड पॉइंट है, तो मिड पॉइंट थ्योरम यूज नहीं हो सकती. सेकेंड ऑप्शन कन्वर्स ऑफ मिड पॉइंट थ्योरम, जिसमें सिर्फ एक साइड का मिड पॉइंट चाहिए होता है, तो वो यहाँ पे पॉसिबिलिटी है बिकॉज मेरे पास दोनों ट्राइंगल्स में सिर्फ एक एक साइड का मिड पॉइंट है. सो दैट्स पॉसिबल दैट आई विल बी एबल टू यूज कन्वर्स ऑफ मिड पॉइंट थ्योरम. लेकिन कन्वर्स ऑफ मिड पॉइंट थ्योरम में सेकेंड कंडीशन ये है कि साइड पैरेलल होनी चाहिए. मिड पॉइंट में से जाने वाला लाइन सेगमेंट टू सेकेंड साइड ऑफ द ट्राइंगल इट शुड बी पैरेलल. सो यहाँ पे अगर आप इस ट्राइंगल पे फोकस करते हो, इन ट्राइंगल जस्ट let's just focus on this triangle here, triangle APB. I have the midpoint of side AB. So एक मेरे पास midpoint है, जो लाइन E में से जा रही है, this line, this should be parallel to the second side of the triangle. If I can prove that somehow, if I can prove that EQ is parallel to AP, if I can prove this, then I will be able to apply converse. It's not given to me. I have to prove that EQ is parallel to AP. Similarly, if I take the other triangle is this one. In this triangle, the midpoint is F. The line which passes through this midpoint, it's FP. I want to prove that FP is parallel to this side. So if you look closely, these are actually the same line segments. जिनको मुझे पैरेलल प्रूव करना है कन्वर्स यूज करने के लिए, वो एक्चुअल में सेम ही लाइंस हैं. हाउ डू आई प्रूव दीज टू पैरेलल? आई विल बी प्रूविंग
parts of parallel line.
Yes, these are parts of parallel lines. But is FA parallel to CE? You could say that's correct, parts of parallel lines, but
And AE is also equal to CF.
AE is also equal to CF.
E will be parallel to CF2.
That's correct.
And can we make this a parallelogram?
Yes, that's what we will be doing.
AECF.
Theorem 8.8. Theorem 8.8.
That's correct, Daksh. Wonderful, you remember the results. So we will be proving this quadrilateral as a parallelogram. Once it's proved to be a parallelogram, you will have the opposite sides parallel, and then you can apply your converse of midpoint theorem in each of these triangles. Students generally miss this part. To prove that it's a parallelogram, they directly use the result कि हमारे पास midpoint है और midpoint से जाने वाली जो line segment बन रही है वो second side के parallel है, तो third side का midpoint बन जाएगा. They forget to prove that the lines that you're using in your converse of midpoint theorem to be parallel, वो दी नहीं, आपको prove करना है. Let's write the answer once. Kudrat is asking, beta, trisection means three equal parts. You have two words. One is bisection and the other one is trisection. Bisect means two equal parts and trisect means three equal parts. I'm going to indicate just for you to remember. The first step here will be to prove that AECF is parallelogram. The quadrilateral formed here in the middle. This is a parallelogram. And for this, I'm going to use the properties of the original parallelogram. ABCD is a parallelogram, so the opposite sides will be parallel and equal. Since the opposite sides are equal and parallel, their halves will also be equal and parallel. Remember one thing, every time you write down half of something in your proof, you're writing down, or concluding a result where you're writing down half of something, please ensure that you're given the midpoint of that side. Unless आपको midpoint दिया हुआ है, तब तक आप नहीं use कर सकते half वाला result. So I'm going to just write down, since ABCD is a parallelogram, this implies AB is parallel to DC and AB is equal to DC. These are the opposite side. And since I have the midpoints for both of these, I can write down the result for their halves. Their halves will be parallel and their halves will also be equal. Now AB has two halves, AE and EB. These will be parallel to the parts of DC, which are BF and FC. Please pick the suitable ones. And similarly, halves are equal, so that means AE is equal to EB. This is equal to DF equals to FC. Two parts of AB are parallel to the two parts of DC, and two parts of AB are equal to two equal parts of DC. I'm going to pick the ones which are suitable to me. I'm going to pick AE and FC. So AE is parallel to FC and AE is equal to FC. These are the opposite sides of quadrilateral AECF. They are equal as well as parallel. Therefore, quadrilateral AECF is parallelogram.
Ma'am,
Yes.
ma'am, why is it necessary to have midpoints while using half?
Half, beta, if you don't have the midpoint, how would you identify the half? Unless you have the midpoint, you will not be able to identify the half. आप half लिख दोगे, उसके बाद आप कौन सा portion pick करोगे? आपके पास point marked होगा ना midpoint. Like right now, I had the midpoint E for AB. That's how I could write down AE and EB as the two equal parts. अगर मेरे पास यहाँ पे point नहीं होता, suppose मेरा parallelogram इस तरह से होता. अब मेरे पास points नहीं है. So I could write down the same result. AB is parallel to DC. AB is equal to DC. I can write down the result further. मैं half भी लिख सकती हूँ. लेकिन इसके बाद मुझे पता नहीं चलेगा कि मुझे आगे क्या करना है. What do I do further? Because मेरे पास points नहीं है ना यहाँ पे. Points होंगे तो ये लिखने का फायदा होगा. Otherwise it's of no use. इससे आगे फिर हम नाम क्या यूज करेंगे? Unless point हो. तो point होगा तभी हम फिर आगे वो parts mention कर सकते हैं जो half बनते हैं. That's what I'm trying to say here.
Okay, ma'am.
So I hope this first step is clear to everyone. How do we prove this quadrilateral parallelogram? Now I can write down that the other pair, एक pair यहाँ पे मैं लिख चुकी हूँ, already parallel है. AE is parallel to FC. The other pair of opposite sides will also be parallel. AF will be parallel to EC. This is what I wanted to prove in order to use my result. This side is parallel to this side. So now you can use the parts of these two. If I would go back to the figure here, This side AF is parallel to EC. I hope I've written correctly. Yes, AF is parallel to EC. I can now use the parts of these two. From AF, I will be picking AP parallel to EQ in triangle APB. And in triangle DQC, I will be picking these two to be parallel. Let's write down the answer. Further, I'm going to use the two triangles that I had shown you earlier. Apply converse in triangle APB. In triangle APB, this is given to be the midpoint. Over here, I have point Q, and I have proved that these are parallel. Midpoint of one side, line segment through that parallel to the second side. EF is parallel to, just a minute here, it's EQ parallel to, EC is parallel to AF. You can also write down the result which has been marked as star. So by converse of midpoint theorem, we get the midpoint of the third side. Since Q is proved as the midpoint, I can write down that the two parts are equal. Now I'm going to write down, use the converse of midpoint theorem in this triangle. In triangle DQC, I have F as the midpoint already. For one side, I have the midpoint given to me. The line through this is parallel to the second side. So FP is parallel to CQ. Same reason, because of star, these are parts of parallel lines. Eventually, point P will be the midpoint of the third side. And from here, I can conclude that DP equals to PQ. Combine the results obtained by applying the converse of midpoint theorem in two triangles, result 1 and result number 2. From 1 and 2, you can conclude that DP is equal to PQ is equal to QP. So the three parts of the diagonal BD are equal. That means that the diagonal has been trisected. This is what we wanted to prove. If you go back to the to prove part, this is what we had written. DP, PQ, QB, three parts of the diagonal BD, they are equal. Any questions here?
No, ma'am.
Step 2 and step 3 are actually similar to the previous question. We have two triangles. We apply converse of midpoint theorem. The first step is actually very important in order to do step 2 and 3. The parallel condition that we require for converse, it's to be done with the help of step number 1. अगर आप वो नहीं करते हो तो फिर आपके वो आंसर आपका गलत हो जाएगा. You would get credit but not full credit. If you're writing down, let me know.
No, ma'am.
Okay, question number 6 we had done right after question number 1. We are left with just one question, and I think you will be able to do that on your own actually. So we have a triangle ABC, which is right angled at C. That means you have a right triangle. There is a line passing through the midpoint M of the hypotenuse. M is the midpoint of the hypotenuse. There is a line which passes through this point, and that line passing through the midpoint is parallel to the second side, BC. एक साइड का मिड पॉइंट दिया है, उस मिड पॉइंट में से लाइन ड्रॉ की गई है जो सेकंड साइड के पैरेलल है, और वो थर्ड साइड को पॉइंट डी पे इंटरसेक्ट करती है. सो बाय नाउ आई थिंक यू वुड नो कौन सी थ्योरम अप्लाई होनी है. इट्स कन्वर्स ऑफ मिड पॉइंट थ्योरम.
Converse of midpoint theorem.
What can you say about the point D? It will be the midpoint of the third side. So the first result that you can see here actually simply is concluded with the help of converse of Pythagoras theorem. I would like to draw a triangle just to show. So let us say this is the triangle that we have. Let's keep in mind C is your right angle and AB is your hypotenuse. We have the midpoint for this side, M. These two paths are equal. There is a line which passes through M and is parallel to BC. So BC is vertical. The line through M will also be vertical. So there is a line which passes through M. This line is actually parallel to BC. And it meets the third side at point D. Let's name this line as M. So D will also be the midpoint of AC, converse of midpoint theorem. And then the next result, MD is perpendicular to AC. Can you prove that? You can see MD here, you have to prove.
We can use the property of sum of co-interior angles.
Yes, you can use the property that sum of co-interior angles will be 180, co-interior angles will be supplementary. In that case, you take these two triangles. Sorry, these two angles, angle number 1 and 90 degree here. These two will be supplementary, and hence angle 1 comes out to be 90 degrees. That makes MD perpendicular to AC. Or you could write down that this angle, angle 1, is equal to this angle, corresponding angles. Angle 1 will be directly equal to 90 degree because they are corresponding angles, which makes MD perpendicular to AC. And then finally, you have to prove that CM equals to MA equals to half of AB. ये जो second वाला part है, ये तो true है. MA is half of AB because M is side का midpoint है. M is the midpoint of AB, so MA is half of AB. ये portion correct है. You have to prove the first two segments equal to each other, CM and MA. I can see MA.
CMD is congruent to AMD by SCS.
That's correct. We will be proving this particular result with the help of congruence. Now, if you realize or if you observe, you can see MA, but you cannot see CM. So CM will have to be joined. And we are going to take these two triangles, the ones on the bottom that you can see. CMD and AMD. We will be proving that these two triangles are congruent, and hence we will have these two parts equal by CPCT. Let's write it once and we will go over the proof. If you have done it already, you can write down on your own.